want to share with you the concept of an orthocenter, which is basically where all the altitudes meet. Often we think about altitude as being how high you are, but here we're thinking about how perpendicular you are. Let's have a look. So the challenge here is to find the orthocenter of the triangle by graphing the perpendicular lines to the sides of the triangle. So here's the first triangle that we want to look at. And remember that an altitude is nothing more than a perpendicular segment from a particular vertex to the line containing the opposite side. So basically, from here, you could see I'd want to drop a perpendicular to this side right here. From here, I drop a perpendicular to this side here. From here, I drop a perpendicular to this side here. And the really cool thing is that if you draw all three of those lines, they will, in fact, all meet at one point, and that's the orthocenter. If you want to find the orthocenter, it's not a big deal. All you have to do is find two of those lines, and wherever they intersect, we know the third one must intersect there because that's the theorem. So you only have to find two. So which two perpendicular lines or two altitudes should we find? That's enough, by the way, once we find those two, to give us the orthocenter, because that's where they all intersect. Well, to me, this is an easy side, because this side I can see literally is riding just on the x-axis. And so I know that it's horizontal, which means that perpendicular to that is going to be vertical. And so from this point, all I got to do is just drop straight down. And when I do that, I will see the line is going to be just x equals this value, which is x equals 4. So in fact, this is a real easy one. So we got a nice little gift, and I love gifts. In case you're wondering, gee, I wonder if Professor Berger likes gifts. The answer is yes. So now we see that this is in fact perpendicular, and we're good to go. Now all I need to do is find another altitude, and I'm done. Well, where can we find another altitude? Well, you could pick either of these sides. I'll just pick BQ for fun. And how do I find the line that's perpendicular to this and goes through the origin? That's going to be an easy point because that's just the point 0, 0. So if I just find the slope, I know it's going to be y equals that slope, and that's it. So what's it going to be? It looks like it's kind of down here. How would I find that? Well, I could find the slope of this line, and then remember that if I know the slope of this line, the slope of a line perpendicular to this is going to actually have slope that's the negative reciprocal of this. So if I take this and look at the negative reciprocal, it'll give me a slope that is perpendicular. So armed with that, let's just find the slope of this, which of course is the change in y divided by the change in x. And if we do that, we see that the slope is negative 4. So what's the negative reciprocal of negative 4? It would be negative 1 over negative 4, which is 1/4. And so I see that the slope of the altitude that we want across BQ is going to be 1/4. And since it passes through the origin, I know exactly what the line is going to be. The line is going to be y equals 1/4 x, technically plus 0, because that's the y-intercept. So if I put that line in, that wasn't too hard to find, but I wouldn't call it a gift. I wouldn't call that a gift. So that looks like this, basically. And so that's pretty good. And so we see now these two lines. This is now perpendicular here, just to make sure that we're really on the same page. This is designed to be perpendicular. And we now see that point of intersection. So that point of intersection is right here, which we can actually figure out exactly what that is. And how would we do that? Well, we just look for the intersection of these two lines. Well, this is the line x equals 4, which means we automatically know that x equals 4. So to find the intersection of these two lines, I know it's going to be x equals 4. And how do I find the height? Well, I could plug in 4 in for this line for x and see what the height is. You can almost read it off, and you can see y equals 1/4 times 4, which equals 1. And maybe you actually read that off already. That's actually at 1. So I see 4, 1. And so that, in fact, is the orthocenter. So we see that the orthocenter is at 4, 1. And you can see it right here, 4, 1. Isn't that cool? Very, very neat. Let's try another example where we can see this idea in even a richer way with a slightly different example. This example is going to be an obtuse triangle. Let's check it out for ourselves. Same exact question. Let's find the orthocenter. So if we look at this, what do I see? Well, I see that, again, this side AB is an easy side.